Competitive learning. So as the name implies, in competitive learning, the output neurons of the neural network compete among themselves to become active. If you remember Hebbian learning, several output neurons may be active, but coming to competitive learning, at a time, only a single output neuron is active. So if you observe here, all the input neurons are connected to all the output neurons. So these are the layers of input nodes. So wherein we can call them with x1, this is x2, this is x3, and this is x4. And the outputs are y1, y2, and y3. Also we have the synaptic weight connections here. So this one is W11 and this one is W12, this one is W13 and this is W21, 22, 23, 31, 32, 33, 41, 42 and 43. If you see here, not only the input nodes are connected to the output neurons, but these output neurons in turn are connected with each other. That is, y1 is connected to y2, it is represented by this arrow, and y2, the output neuron y2 is connected to y1, and this output neuron y2 is connected to y3, and y3 is in turn connected to y2. Also in the last you see y1 is connected to y3 and y3 is connected to y1. Now the connections between these input nodes and output neurons y1, y2, y3 and the input nodes x1, x2, x3 and x4, these connections are called feed forward connections or excitatory connections, and the connections between these output neurons are called as lateral connections or inhibitory connections, which means one output neuron is trying to inhibit the activity level of other output neuron. Let us now take a small analogy to understand the competitive learning better. So let us think that we all are in a single class. Now all of us get the same kind of inputs, which is nothing but we all read from the same textbook, we all listen to the same video lecture or audio lecture, and we all read the same websites and information. So we all try to learn good amount of information from the same sources. But you remember, at the end of the day, after conducting an exam, only one person will be the winner who is going to get the top marks, that is, he will be the topper. So the same happens in the competitive learning also, that is, only one of the output neurons among these three neurons is going to win. Let us say, for example, y2 wins. So y2 will be active at the end of the iteration. So here one output neuron tries to inhibit all the other output neurons. Why? So let us say we have a guy who is a topper. So always he wants to be the topper. So he don't want to let his secrets to be known to all the other people in the class, because the other people in the class may become topper for the next exam. So here that particular topper is going to inhibit all the other people who are writing the examinations by not telling the secrets. So in the same manner, here one output neuron inhibits all the other output neurons. So finally we say that in competitive learning, only a single output neuron is active at any given time. So it is this feature that makes competitive learning suitable to discover features that are used to classify a set of input patterns. Let us now discuss about the three basic elements to competitive learning rule. The first element is a set of neurons that are all the same except for synaptic weights. It means all the input neurons are structurally similar. The only difference is the synaptic weights at the beginning or the initial synaptic weights will be different. That is, they are randomly distributed. Therefore, they respond differently to a given set of input patterns. The second basic rule is a limit is imposed on the strength of each neuron. It means there exist some constraints on the synaptic weights of the neurons. That is, the constraints could be sigma wkj, which is iterated over j, is equal to 1 for all k, and the another constraint is sigma wkj square iterated over j is equal to 1 for all k. So, these constraints which are kept on the synaptic weights of the neuron depends on the environment. The third basic element is a mechanism that permits the neurons to compete. That is, neurons compete for the right to respond to the given subset of inputs, such that only one neuron per group is activated at a time. So, the neuron which wins the competition is called a winner takes all neuron. So, now the question is, how do we choose a particular neuron as a winning neuron among all the other neurons? So, for a neuron K to be the winning neuron, the induced local field Vk for a specified input pattern X must be the largest among all the other neurons in the network. It means for all j, Vk is greater than Vj, that is, the induced local field of this neuron K must be greater than any of the other neurons in the given network where j is not equal to k. So then the output signal Yk of this winning neuron is set to 1, and the output signal of all the other neurons which lost in the competition are set to 0. So this is how we write Yk equal to 1 if Vk is greater than Vj and Yk equal to 0 otherwise. And now let Wkj denote the synaptic weight connecting the input node j to the neuron k, and let us suppose that each neuron is allotted a fixed amount of synaptic weight which is distributed among its input nodes, that is, sigma wkj iterated over j is equal to 1 for all k. So, the neuron then learns by shifting the synaptic weights from its inactive to active input nodes. Say for example, if a neuron does not respond to the particular input pattern, then no learning takes place. Whereas, if a particular neuron wins the competition, each input node of this neuron, which are these, relinquishes some proportion of their synaptic weights, and the weight relinquished is then equally distributed among the input nodes which are active. Now, according to the standard competitive learning rule, the change, that is delta wkj, that is the change in the synaptic weights applied to the synaptic weight wkj, is defined by the following formula. Delta wkj is equal to eta into xj minus wkj if the neuron k is going to win the competition, and delta wkj is equal to 0 if the neuron k loses the competition, where we already know that eta is the learning rate parameter. So, this rule has an overall effect of moving the synaptic weight vector wk of this winning neuron k towards the input pattern x. So, here we have some assumptions, that is, each input pattern x has some constant Euclidean length which can be viewed on n dimensional unit sphere. So, here n denotes the number of input nodes which also represents the dimension of each of the synaptic weight vector wk. And the third assumption is all neurons in the network are constrained to have the same Euclidean length with the constraint sigma wkj square iterated over j is equal to 1 for all k, which means let us say we have an input vector x which is having x1, x2 so on up to xn, and the synaptic weight vector wk which is nothing but wk1, wk2 and so on up to wkn. So over the time, as the learning process takes place, this weight vector wk approaches this input vector x. So this is how the output neurons becomes the feature detectors. So let us make this point more clear. That is, the point is, this rule is having an overall effect of moving the synaptic weight vector wk of the winning neuron towards the input pattern x. So if we plot these input vectors and the synaptic weight vectors on a three-dimensional plane, it looks like this. Here the dots in the yellow color represents the input vectors and the crosses in the red color represent the synaptic weights vectors of three output neurons. So over the time, due to learning, what happens is this synaptic weight vectors approaches the clustering of input vectors. That is, after learning, the synaptic weight vectors now will be at the center of the groupings of these input vectors. So this is the final state of the network after the learning takes place. Let us take, for example, this particular output neuron has specialized in detecting this group of inputs, and this output neuron has specialized in detecting this group of inputs, and same with this output neuron also. So now let us consider the case where we have two different groupings of input vectors, which you can see one grouping is in red color dots and the other grouping is in yellow color dots, which are very close to each other and they are in overlapped state. Let us now suppose that a synaptic vector has approached this clustering, but due to overlapping of these inputs, the synaptic weight vector will not be stable. So this synaptic weight vector oscillates between these two different groupings of inputs, thereby making the system unstable. So this is the shortcoming of competitive learning. So this is how a competitive learning takes place. Thank you.